Even if you don't like sports, you got to admit this is math cool. Okay, so here's the situation. The home run data. Okay. Um, I did this last year, and though I can't find the data, I can tell you this. The X bar is 202.8. The average number of home runs for Major League Baseball teams was 202.8. And the standard deviation for that is a fat 38. So those teams were off of the mean by 38 home runs on average. That kind of makes sense, doesn't it? The Yankees' number of home runs that year was 276, above the mean, way above the mean. Let me go to NBA three-point averages. The mean for three-point averages, probably for like starting guards, if I remember correctly, was X bar equals 2.47. And the standard deviation, that was 0.67. They're all pretty close. Because, I mean, how many three-pointers does everybody make per game versus how many home runs do teams hit for a year? It makes sense that that standard deviation is small. Curry's average that year, 5.1 per game. Okay, I'll go to touchdowns. The mean number of touchdowns by quarterbacks in that year was 18.1 with a standard deviation of 12.4. Makes sense since you have quarterbacks having all kinds of touchdowns that throughout the season that you're going to have a bigger standard deviation. So those three numbers sets of numbers should make sense. Now, here's what we're going to do. I'm going to take the Yankees home runs, bigger than the mean. I'm going to take Steph Curry, bigger than the mean, and I'm going to take Mahomes. His number of touchdowns, I never wrote it down, sorry, was 53, much bigger than the mean. I'm going to find out who had, statistically now, who had the best year. This baseball team, this basketball player, or this football player. Those are things that you shouldn't normally be able to compare. The Yankees z-score goes like this. Z equals 276 minus 202.8 divided by 38. The Yankees z-score for that year for how many home runs they hit was 1.93. Now think of that girl and her height. She was more than one standard deviation below the mean. That meant she was pretty short. Look at this. The Yankees are almost 2 standard deviations above the mean. That means they're way ahead of everybody. Steph Curry, his z-score goes like this. Z equals his 5.1 average minus 2.47 on an average, and it's divided by 0.67. Steph Curry's z-score is 3.93 for that year. He's almost 4 standard deviations above the mean for his competitors. And then the last one, Mahomes. Man, did he have a couple of good years. 53 minus 18.1 and divide by that standard deviation of 12.4. And Patrick Mahomes comes in with a z-score of 2.81. He is almost 3 standard deviations above the mean. So checking those numbers and these outstanding performances, best in all of their leagues that year, who really had the best year compared to their competitors? That one right there. Since the largest z-score is z equals 3.93 for Steph Curry, at times, man, it seems like he couldn't miss. Curry had the best season in 2019 compared to everyone else that year. So question, how would this be different if we were comparing number 1 golfers and swimmers and the time it takes UFC fighters to knock out their opponents? Well, we would be looking, because those sports work differently, you're trying to do things the quickest, not get the biggest number. You're trying to get the lowest number. We'd be looking for the lowest negative z-score. Make sense? I know you think that's cool. Even though math isn't cool, I know you think that comparing things like that together is cool. On page 106, your homework is number 13, 15, 17, 18, 19, and 20. Have a good day, everybody.